Welcome to Scale Up University. Welcome to Probability for Machine Learning course. So this is the lecture 3 of module 1, and in this lecture we will be discussing what is probability theory. So we'll be discussing about probability theory. So module 1 is what is probability, and this is the lecture number 3 of module 1, and this lecture is what is probability theory. So basically in the previous lecture we saw how we can measure uncertainty using probability. So in the previous lecture, we saw how to assign a probability to one event, like a independent event. So how we can assign a probability to one event. But in machine learning, never deals with just one event. Actually, in machine learning, you will see that it will deal with many variables. There will be many features which will influence the target. So machine learning deals with many variables. It deals with many outcomes. Machine learning deals with many probabilities interacting at once. So here comes probability theory into the picture. So whenever many events are involved, many probabilities interact with each other, then we have to make use of the probability theory. So probability theory helps us to reason correctly when many uncertain events interact with each other. So the idea is very clear. Whenever we have multiple events, so every event will have a probability associated with it. So when many probabilities interact, when many uncertain events interact, then how we can reason correctly? So for that, we can make use of the probability theory. So probability theory is about that only. And that is what we will discuss in this lecture in detail. Because this lecture is all about probability theory. So if we look at the key topics of this lecture, so first we will discuss from individual probabilities to a theory. Then we will look into the definition of a probability theory. So we got some idea about probability theory, like what exactly it is, how it is different from probability. And then we will look at what probability theory provides. Then we will look at why probability theory matters in machine learning, the importance of probability theory in machine learning. And finally, we will conclude this lecture with by comparing probability with guesswork. So probability is not a guesswork. Probability is very much different from guesswork, and that we will discuss. So these topics we will cover in this lecture one by one. So first, let us look at the first topic of this lecture, that is from individual probabilities to a theory. Now we'll see why single probabilities are not enough. Now let us look at one example. If I say probability of getting a spam is 0.8. Now see here, basically we are quantifying an uncertainty. So definitely this is a useful data. Like here we are telling that, okay, given a email, what is the probability of it being a spam? That is 80%, but it is incomplete. Now that is the question, why it is incomplete? It is incomplete because when we have to calculate the probability, we have to also consider many other factors which we haven't considered while calculating the probability that the given email is spam or not. Because for an email to be spam, there are many factors which plays a role, and we haven't considered those factors. And because of that, whatever prediction it is making, whatever probability value it is assigning, that is incomplete. That's not totally correct. So we are not answering questions like, or we are not considering these cases like what happens if the email has an attachment, because it is obvious that email with attachment will definitely alter this value, because email with attachment will influence this probability. So here we are not taking into that into consideration. We are not considering how does probability change after seeing new data? So new data points will definitely influence the probability. So how exactly it will change? We are not considering that scenario in the above formula or in the above calculation, because above calculation is mainly like more of like a frequentist probability, wherein it is calculating based on the frequencies. And we are not considering how do multiple probabilities interact. So that's why single probabilities are not enough. So in real world scenario, we will be dealing with the scenarios wherein multiple events interact with each other. And when multiple events will interact with each other, multiple probabilities interact with each other. And when multiple probabilities interact with each other, how to deal with it? How to analyze it? What is the mathematics for that? So that is what is probability theory is all about. So we need, so there's a need for a system of rules. Just probability alone is not sufficient. We also need system of rules, because without rules, probabilities just become isolated numbers with no logic connecting them. And probability theory provides us those rules using which we can logically connect multiple probabilities and make informed decisions. We can reason all that we will learn in this lecture itself. If we look at one machine learning example, feature interaction in classification. Now, if I like calculate the probability of spam, let us suppose it is 0.6. But if I calculate the probability of spam, given that it contains the email contains the keyword free in it. So here what we are doing is that, and this let us suppose we are getting 0.9. So here we are considering multiple events, because see, in the previous scenario, we just took an email and just calculated whether it's spam or not. But in the below scenario, second scenario, like we are taking an email and it's one more additional information is given about the email, that it contains the keyword free. It contains the keyword free. And because of that, the probability of that email being spam has got increased because of this free keyword. High chances of that email to be a spam. Now we should have some systematic rules to deal with it. So a machine learning model must combine evidence systematically, not emotionally. Like there should be rules, systematic rules using which we can calculate that the probability of the given email to be spam, provided it contains the free keyword. And that rules we will study in probability theory. Probability theory defines those rules, because those rules will help us. It will define how to update beliefs. So here, probability of spam 0.6, it is a belief. And when we got a evidence that the email contains free keyword, so this is the evidence. And because of with this evidence, the belief got updated, because earlier the belief is 60%. But with this evidence that the email also contains the free keyword, the belief got updated to 90%. Now, how it got updated? What is the exact rules for that? That is what is covered in probability theory. So probability theory defines how to update beliefs. It defines, or it says if reasoning is consistent or not. So now we are getting an idea from individual probabilities to a theory. Like now we are getting an idea that what is the need for probability theory. Now we will look at the next topic of this lecture, wherein we will be defining probability theory, definition of probability theory. So we got an idea, like we got a feel that need for probability, we got an understanding. But now we will exactly define probability theory. definition of probability theory. So if I talk about probability theory, it's a branch of mathematics which is focused on uncertainty. Probability theory is a branch of mathematics which is focused on uncertainty. It's a branch of mathematics which is concerned with reasoning under incomplete information. Now that's the beauty of probability theory. Like whatever information we have, like whatever output the machine learning model predicted, it's uncertain. We are dealing with incomplete information because we already saw in one of the lectures that while we are training the model, we are not taking all the possible data, rather we are taking a sample of the reality. So like let us suppose billions of males exist in the world, but for training we will take only few millions. So we are taking a subset or a sample from the population, and hence we are dealing with incomplete information. And because of that, probability theory will come into the picture. Probability theory will help us in reasoning under incomplete information because it is focused on uncertainty. Now let us look at one example. Let us suppose I have a probability of classifying the output as A to be 0.7. So the probability that the given input is A is 0.7. Now here, initially there was some uncertainty. See, what is happening is that our machine learning model is predicting something. So it might predict A or it might predict B. Like it is a classification model. The machine learning model is a classification model. I'm giving it an input. Either it can classify the input as A or B. So there is an uncertainty is involved. And we already saw that we can measure the uncertainty using the probability. So what is the chance that the model will predict the input or model will classify the input as A? That is 0.7. So we measured the uncertainty. So with probability, we can measure the uncertainty. But probability alone is not enough. Now, what will happen is that because in the real world scenario or in the machine learning world also, here we have just one information or just very limited information. Based on that we made this prediction or we made this classification. But what if we get some more evidences? Then definitely this probability will change. So all those things, like here we are dealing with, let us suppose, only one event, but what if there are multiple interacting events which come into the picture? What if we get some more data, some more evidences? Then definitely this belief we have to update, and how we will do all that is what is been covered by probability theory. And using the rules, systematic rules of probability theory, we take reliable decisions. So here one very interesting thing we should observe: probabilities measurement of uncertainty, and probability theory is the grammar of uncertainty. Like it contains some systematic rules. Like in the grammar, we have rules which will help us in taking reliable decisions, which will help us to reason despite having incomplete information. Probability theory ensures probabilities can be compared. Probability theory ensures probabilities can be combined and updated. Like let us suppose we have many possible outcomes. So every outcome will have a probability associated with it. Now, how to compare? So probability theory gives us the tools. It will gives us the systematic rules to compare probabilities, to combine probabilities, how we can combine interacting events, the probabilities of that, and how we can update the probability given a new evidence. Like we have a belief, and with the emergence of new evidence, that probability has to be updated. So Probability theory gives us the systematic rules to update those probabilities. So now it's very much clear to us that probability is the measurement of uncertainty and probability theory is the grammar of uncertainty. It adds real value to probability. So we can make one very interesting, like we can say that without probability theory, probabilities are just decorations. Because without the systematic rules, without the probability theory, whatever uncertainty we are measuring, they are just numbers. They are just like alphabets. Without grammar, it will be like just like alphabets. So they are just numbers. So probability theory, like the systematic rules, it adds real value because it enables us to take reliable decisions. It enables us to reason from the incomplete information. Okay, now we'll look at the next topic of this lecture. What probability theory provides? So probability theory, it provides axioms and derived rules. So we already saw that probability theory, basically they are systematic rules. So they are axioms. And what are axioms? Axioms are basically basic rules that must always hold. So axioms are basic rules that must always hold. So probability theory provides axioms and probability theory also provides derived rules which are used for reasoning. So using axioms and some other facts and evidences, we get derived rules and these rules play a very important role in reasoning. Now we already saw that probability theory, it helps or it provides mechanisms or systematic rules to combine probabilities. So probability theory provides combining probabilities, like how we can combine individual probabilities. So when combining probabilities come into picture, see when multiple features interact or when multiple events occur together, in those scenarios, there is a need to combine individual probabilities and probability theory provides us the systematic rules for combining probabilities. Probability theory also provides comparing probabilities. Like when multiple features interact, when multiple events occur together, we have multiple individual probabilities. And probability theory, it gives us the systematic rules to compare those individual probabilities. So we can rank outcomes. We can choose most likely predictions. We can even decide thresholds with the systematic rules for comparing probabilities. Probability theory also provides updating probabilities. Like it provides the systematic rules using which we can update probabilities. So see, the idea is that we already like we have a prior belief, like a probability. Now, when new data arrives, then that like there is a need to update the probability. When we accumulate evidence, when evidence accumulates, there is a need to update probability. When models are retrained, because whenever we train the model, we do it in several epoch like iterations to update the weights. So when models are retrained, there is a need to update the probabilities. Now, how exactly to update the probabilities? That is defined by the systematic rules of probability theory. Probability theory also provides logical consistency. So probability theory ensures there are no contradictions because the systematic rules are designed in such a way that there is no scope for contradictions. Logical consistency ensures there is no impossible beliefs, and logical consistency, it ensures no probability is greater than 1 or less than 0. So Probability theory, like the systematic rules, they provide logical consistency. Very important. It ensures that there are no contradictions, there are no impossible beliefs, and no probability greater than 1 or less than 0. If we look at one example, let us suppose we have we have an input, and what is the probability that it is a disease, and let us suppose that is 0.01, and the same probability of getting a disease provided an additional information that is positive test. So the test result was positive. So see, the idea is that here the input is symptom. So we are giving some symptoms to the machine learning model, and it is predicting the probability of disease. So with those symptoms, the probability of disease is like just 1%, 0.01. But we also gave it some more evidence that the test was positive, and because of that the probability it increased, it became 65%. Because of the positive test, the chance of the disease increased, it became 65%, 0.65. So here what happened was, we had a prior belief, but with the evidence the belief got updated, and we got updated belief. So we can say that learning is probability theory in motion. Because what is happening is that, like when we are learning, so what is happening is that we are already having some prior belief, and with new evidence, with the emergence of new evidences, we are updating those beliefs. And how we are updating those beliefs? So we are updating beliefs using some systematic rules which falls under the probability theory. So probability theory helps us in updating the belief. So learning is probability theory in motion. So what is happening is that we have a prior belief, we are getting evidence. Now probability theory will give us the systematic rules how to update the belief using this evidence. And that is what is learning. And this process, it keeps on going and going. So learning is probability theory in motion. Learning in machine learning is belief updating under rules. So learning in machine learning is belief updating under rules. So the idea is very clear, because see, in machine learning also, it's all about getting the most optimal weights. It is all about predicting the weights. And we start with a random weight, and that is the belief. We start with a random weight, and whatever data we have, training data, labeled data, that is the evidence. So we started with a belief, we got the evidence, using that belief we did some prediction, and we compared our prediction with the ground reality, with the evidence, and the difference was the error, the loss. And the loss gave us the idea that okay, our belief is wrong, or we are in the wrong direction. So we are updating the belief so that we minimize the loss. And in this way, that is what is machine learning is. So we are updating the rules, like we are updating the beliefs under rules. And those rules are like different algorithms, like gradient descent. So many ways are there. And interestingly, most of them, probability theory plays a role. Like the probability theory is the core of that. Okay, now we'll discuss the next topic of this lecture, that is why probability theory matters in machine learning. Now if we talk about machine learning problems, so basically they are stochastic. So there are random variations in the data. So we have data with significant variance. So machine learning problems are stochastic in nature. Data is limited. So machine learning problems deal with limited data set, because all the trainings we provide, we do with finite samples. finite samples from infinite reality. The data we use is noisy. It contains noise. Like we can have measurement errors, we can have label mistakes, we can have environmental randomness. And all these things makes machine learning problem highly uncertain. And to measure those uncertainty, to deal with those uncertainty, we make use of probabilities. And since here probabilities will be interacting with each other, it is not like we will be dealing with single events or independent one event. There will be multiple features or multiple probabilities interacting with each other, and automatically probability theory will come into the picture. So probability theory plays a role in machine learning. So we are seeing probability theory as machine learning foundation. So basically probability theory plays a role in training the model, like in calculating loss functions and also in likelihood maximization. Probability theory plays a role in model evolution. Sorry, model evaluation. Model evaluation, like confidence scores and risk sensitive metrics. And probability theory also plays a role in doing prediction under uncertainty, like dealing with probabilistic outputs and confidence aware decisions. So probability theory, like it's the foundation of machine learning. It's very important because machine learning problems are highly uncertain. I'm extremely sorry for this. It is uncertain, highly uncertain. So highly uncertain. Uncertainty is there in machine learning problems. Because of that, probability theory will come into the picture. And probability theory plays a role in model training, model evolution, prediction under uncertainty. Okay, so now let us look at the last topic of this lecture, that is probability versus guesswork. So definitely probability is different from the guess, and that is what we'll discuss. So probability is not intuition. So if we compare guesswork with probability, so guesswork talks about feels right, feels wrong, feels safe, feels risky, but probability talks about the numeric nature, is numeric. Like probability is numerical in nature, na? So probability assigns a value, and that value g- it gives us the clarity. But guesswork is about, in guesswork there is no number is associated. Guesswork is not numeric. It contains keywords like feeling safe, feeling feels risky, feels right, feels wrong. So guesswork is subjective because no quantification is involved. But probability, it is rule based. Probability is rule based. Guesswork cannot be audited, but since probability is rule based, it is numeric, it can be checked. So now we got a very clear understanding why probability is not intuition, why probability is not guesswork, because probability is rule based. It is numeric, it can be checked. Guesswork is informal belief. Like, for example, I think this will happen. But if we talk about probability, it is formal reasoning. So here we say that based on data and rules, belief is 0.73. So we are quantifying the belief. Probability theory also ensures, I'll write it separately, uh, or I can write it here also. Like probability ensures reproducibility and accountability. So the idea is that two people using same data will give same reasoning. So we can say that probability enables explainable and defensible machine learning, because probability is not something like it's like an intuition or a guesswork. It is like a formal science, it is formal reasoning, it is rule based, you're quantifying, it's numeric, it can be audited, it is reproducible and accountable. And because of that, probability enables explainable, defensible ML. And this is like something very important about probability and probability theory. So students, finally we completed this lecture. So in this lecture, like you saw, what is probability theory, then why probability needs theory, and you got a very good feeling of probability theory, how it is different from probability, what exactly is probability theory, and we also saw the difference between probability and guesswork, and that is very, very important for us. So with this, we completed this lecture. So I hope you got a very good understanding of the concepts which we discussed in this lecture. So do subscribe to our YouTube channel, that is Scale Up University, and also like share this with your friends, share this lecture in your circle, share it with your friends so that they can also get benefited. And thanks for watching. Thanks for your time.